Welcome to the Cisco BCMSN CBT Nuggets video series. This series is cool. I'll just say it like that. Because the LAN is a cool world and it has radically changed in recent years. To move into technologies like wireless becoming mainstream, quality of service, voice over IP, stuff we never have seen before on a local area network environment now being seen. Likewise, Cisco has updated all their certification exams to include all these new technologies, so here we are. We're going to start off by talking about the core concepts and design, the foundation of the switch world. Some of this will be review for you, hopefully, talking about moving the evolution of local area network environments, moving from hubs to switches to layer 3 switches and so on, and designing a proper network using the enterprise composite network model. It's big. It's designed for big networks, but it can fit just about any network environment. We'll then look at campus network design in a high-level view, and this is going to really lay the foundation for all the upcoming videos, which are going to focus in on each one of these segments. Let's focus in on a certain switch block. What's inside of there? How do you secure that? How does our VLAN design strategy happen, and so on. So this is, as I mentioned, the foundation. Last thing we'll talk about is the switch operating systems. The two that are out there, the Cat OS and the native iOS, what you need to know about each one. So if you're ready, I'm ready. Let's get going. In the beginning, there was the hub. Maybe it's not that old, but it's been around for quite some time. It's the foundation of networks, a device that connects multiple other network-capable devices with basic physical connectivity. Now, hubs are still around to this day. They still are sold in just about every major electronics store, but they're slowly being phased out because they've got some huge drawbacks. Number one is they have a single collision domain. Now, simply defined, a collision domain is just how many devices can send at the same time. It doesn't matter how big your hub is, it's only one collision domain, which means all devices can send or receive at one time. That's our half duplex world. Now we've moved out of that world into the layer 2 switching world. And once we moved to a layer 2 switch, we separated our collision domains, where as many ports on a switch reflects how many collision domains we have. So if we've got a 10-port switch, 10 people can send and receive at the same time. We've moved into a full duplex environment. And by the way, not many people know this. Here's your random trivia fact for the day. Did you know that when you buy a 100 megabit per second network card, you are at no extra charge getting a 200 megabit per second network card? Because all network devices are rated at half duplex. Same thing, if you think of a T1 WAN link, right? We think of 1.544 megabits per second, but I'll sell you one for just a little more that will do 3.088 megabits per second because you can run them at full duplex and you can send and receive at the same time. So with layer 2 switches, we gain the ability to have full duplex environments. Now, the problem still was that we had our broadcast domains, meaning how far a broadcast goes before it stopped. Now, regardless of how many switches I connect together, layer 2 switches, I just get a single broadcast domain. The more broadcasts I have, the slower the devices connected to those switches perform because they have to process all that. So we came with the need for routers. And when routers came about, they helped solve our broadcast problem, but slowed the network down in other ways because routers are slow, they're physically limited. So we came out with a layer 3 switch. And when I say we, I mean people smarter than I am. A layer 3 switch is just a switch with a router inside of it, a route processor that's able to move data between these switches and between the routed domains very quickly. And we'll explore the layer 3 switching world plenty more and even discuss what the difference is between layer 3 switching and multi-layer switching as we dig deeper. Now, 10 or 20 years ago, just a couple switches thrown around the network and connected with crossover cables would be just fine for most businesses. But nowadays, if you were to give Cisco a call and say, hey, I've got a company of 50 people, You're going to end up with this massive network design where they're plug-in multi-layer switches and every person has their own VLAN. It's going to be maddening. So Cisco can jump a wee bit overboard with some of their design models, but they do have some good points. Let's imagine that we decided to go into an entrepreneurship, right? And we wanted to create a company that made bobblehead dolls, little dolls that their head wiggle around. And we start off with our 10 employees making these bobbleheads, and they just catch on. Everybody wants the bobbleheads, and they're all buying, and we're like, hey, this is great. Let's hire more people. I mean, when you move from 10 people to 20 people, we're not going to go crazy on a Cisco multi-layer switch environment. We just have a couple switches, right? Connected like you see on the screen right there. And that's just fine. And, the bobbleheads are selling. People are like, you got to get these things. It's like the what was that? The Tickle Me Elmo a couple years back. That was a while ago. And they're just a craze and hiring, hundreds of employees are now coming in to manufacture these bobbleheads, cubicle farms everywhere. And we're still just linking switches together like this. Okay. Whoa. That's where we need to start analyzing our network environment. We've got switches kind of tied together with crossover cables, but it's working, for our 200 employees, but it's not the best because number one, I would say the number one issue with a plug and play switch environment, and what I mean by that is you need more people, just plug another switch in. Number one problem, chance for failure. You can see that in this simple design, if any one of those switches fail, I guess the lucky switches to fail would be these bottom ones down here, right? But if any of those other switches fail, wham, we're toast. Or maybe we think, oh, well, I've got a better design. Let's just, connect them all in right up here directly to our quote unquote core switch, I guess you could say. But what if that one switch fails? Total network outage. So really, at some point, and it's not for every company, but for most, they'll need to do a serious cost analysis and say, okay, if we lost that one switch, if it were to go down, someone steps on the surge protector or whatever, how much is it going to cost us? Does that outweigh, does the cost of failure outweigh what it would cost us to put in a Cisco design model, which we're going to look at in a second? Second problem with the plug-and-play switch world is broadcast traffic. Now, Cisco released a recommendation. It's a couple years old now, but it's still a good rule of thumb that once you reach 500 hosts per network, I mean, 500 hosts all plugged into the same flat switched environment. That's where the broadcast traffic is starting to get a little bit excessive. And it's not so much for the network. I mean, the network's got hundreds of megabits per second that it's got on tap. It's for all devices connected to the network. So as these devices are receiving these broadcasts, they're going to have to process them and see what's going on and so on. And literally, your devices start to slow down the more broadcasts you have. So broadcast traffic is a problem. Multicasting issues. Multicast is becoming the hot new topic of today, especially with IP version 6 starting to make the move into the United States and a lot of agencies around the world. Multicast is going everywhere, and when you have a plug-and-play switch environment, a lot of times multicast is not handled in the right way. Worst case scenario, it's handled just like broadcast and destroys your network. Security issues galore. Everybody has reachability to everybody on the local area networking or local area network, and MAC flooding. That means as this switch network grows, more and more devices are going to be coming in, and the switches aren't going to have complete MAC address tables because they time out. As devices send data or stop sending data, the switches will stop sending it. And the first time they send data, all the switches flood that traffic everywhere. It essentially becomes like a broadcast. You could almost link MAC flooding and broadcast traffic together because that's how those two work. The more devices you have, the more unknown MAC addresses there will be on the network, and that causes more network overhead. So what's our bobblehead company to do? Buy Cisco stuff. A whole bunch of Cisco stuff. And let me know when you do it so I can buy some stock. Seriously though, this design, this enterprise composite network model is designed to scale from a mid-size to enterprise class organization. And the cool thing about it is the model fits just about everybody. But remember, our bobblehead company may not be ready to move directly into something like this. I mean, this is the model as it's proposed, but I mean, how does a company grow? You've got to switch, right? You got too many employees? Buy another switch, connect with the crossover cable. More employees? Buy another switch, crossover cable. And eventually you get to a point where you've got enough employees that, people are like, getting a little creepy. I don't want a single point of failure kind of thing. So let's buy one of these guys. Just go ahead and get a 4500 or 6500 switch and connect users to that. And eventually you start maxing out the blades and you're thinking, oh man, well, we're just keep growing. So let's take our old switches and plug them into that 6500 and get that, as our essentially our core switch of our network, and all the switches kind of plug into that. And I mean, what you're doing as your company grows is almost unintentionally building this model that you see on the screen. All that's happened, when you see one of these switch blocks, hang on, let me just get this little squares out of here. When you see one of these switch blocks down here, it's just kind of an area that's grown, and enough switches have reached beyond to where you needed a core switch, or essentially this inside of the switch blocks is known as a distribution layer, where the switches are now performing routing. Down here is our access layer, where we have the devices that access or physically plug into the network. And all this, one of these blocks is that network that I was drawing up here, just growing network that has grown to a point where we wanted redundant routing switches to where any one device inside of here can fail, and that's okay. We've got backup devices. You can see our servers have redundant connections over here to the switches. Over here is a user block. Users aren't as essential as the server. We can lose a few of them, so they only have a single connection to the switch. But again, we've got our different layers. This is our access layer. This is our distribution layer right here. And eventually, again, we don't move straight into it, but as our company grows, we add the almighty core layer, which is the layer where all of our different distribution blocks connect to. These distribution blocks are what house maybe hundreds, maybe even thousands of employees each. And every single one of them act as a routed domain. It acts as a security boundary. It can act for quality of service, but I'm getting ahead of myself now. That's where we start getting into VLANs. But notice up here, all of this stuff, all this drawing that I've been doing is considered part of the enterprise campus. This, according to Cisco's model, is all on the campus network. And I have a fairly small model right here, just showing a couple blocks, but easily we could have, a connection over here to a block that houses nothing but wireless access points, where we have a wireless access block, and that block has its own security restrictions and its own switches and its own devices all plugging into those switches. So this thing can scale in major ways. Over to the right, you see the enterprise edge. Most people call that the DMZ. That's where we move from the campus network into a network that connects us to the outside world. Now, that outside world could be private T1 lines connecting to branch offices. The outside world could be the internet connection or redundant internet connections, like maybe we have in this diagram right here, going to two different ISPs. Inside of that enterprise edge, we may have servers plugged in to that DMZ that are hosted and reachable from the outside world. But regardless, one of the goals, you can see it's in a box. It's for a reason. The goal is to firewall that enterprise edge off, to separate it from the rest of the campus to where people can't just move from the internet into the campus. So this model, what you see right here on the screen, is Cisco's design that can scale from a network of, well, to see a model like that, what you're seeing right here, I would say somewhere around 500 employees or so, and it can move into the thousands of employees. And those are just rough numbers I'm throwing out there just off the top of my head. But the point is that this model can scale from just about any small size network to as large as you want to get. Now, walking onto the scene with a confident strut is the VLAN. This technology came out in probably around the late 90s and radically and totally changed the entire landscape of networks everywhere. I've never seen a technology move as fast as VLANs have. VLANs provide a logical separation of your networks, and we'll get more into the technical details of them in the upcoming nugget. However, the VLANs allow you to separate your switch blocks. For example, I just took a small piece of our enterprise composite model, just zooming in on two user blocks. Let's say that we have building A over here that has the IT department and the accounting department, and building B has the sales and marketing department. Now, IT has certain rights that the accounting group may not. And same thing, accounting will probably be able to access some files, some folders that the people in IT cannot. And same thing for sales and marketing and so on. And we need to provide a logical separation of those groups within the same building. Not to mention the broadcast performance. I mean, maybe building A has 1,000 employees. We need some way to logically group those employees into their departments and squish down the number of broadcasts that are happening in each one of those. Cisco says that 500 devices is usually adequate on the LAN, but to me, that still seems like a pretty high number. I usually somewhere around 200 devices, making that Class C subnet mask a real handy one. Somewhere around 200 devices, going and splicing into another VLAN. So some of the benefits of VLANs over there on the right, simpler management. Oh, so much simpler. To be able to say, oh, what VLAN is that port on? Oh, well, that immediately tells me what subnet they're in, what access privileges they have, and so on. Troubleshooting ease because you're able to identify what VLAN people are on. If everybody inside of the VLAN is having a problem, that's usually a pointer of where to look. Oh, well, maybe the VLAN interface or the router that's moving them between their VLANs is the problem. If somebody is in the wrong VLAN or not assigned to a VLAN, it really makes troubleshooting much easier. You get better performance, and I already talked about that with the broadcasts and so on. Mental sanity. I will tell you that it will give you more mental sanity to correctly deploy VLANs. And again, correctly is the key word there, because you have these beautiful divides in the network to where I can say this group of ports that belongs to that department, and that I've got this perfect scheme. Now I will admit having a wonderful VLAN design is just the straight up bragging points, because I have seen some network models. I've actually walked into some IT rooms and they have this beautiful network design just printed on plotter paper up on the wall. It's just like, oh, I walk in, I'm like, oh, tears start streaming down my face. I'm like, it's beautiful. It's a great model to be able to just look at it and go, aha, that makes sense. So mental sanity and bragging points. Finally, summarization points. You can group your VLANs logically to provide summarization points. Now, VLANs equals a subnet. It is a one-to-one correlation. So you can see over here in building A, I've got 172.16.0 through 7. Now that's Jeremy's syntax, not exactly the proper syntax. That's just saying I've got 8 subnets, 0 through 7, that are all sitting over there with a subnetted /24 mask. Maybe a couple of those belong to different accounting VLANs. Maybe a couple of them belong to the IT VLANs, and a couple are unused for future growth within that building. Now, I chose 0 through 7 for a reason. I can easily summarize that into a single advertisement as it leaves this distribution layer out to the core, to where it's just a, let's see, I'm trying to do it in my head now, 172.16.0.0, that'd be a slash, yeah, carry the 1, be an increment of 8. That'd be a slash 1, 2, 4, 8, 4, so it'd be a /28. Don't take my word on that. I think that's right. But that would be a single advertisement that would sum up all 8 of those individual subnets into just a single routing entry. The more summarized routes we have, the smaller our routing tables and the more efficient our network. Now, some high-level VLAN design guidelines before we move into the specifics and go through all the VLAN videos that talk about the configuration, implementation, and so on. Number 1 is to restrict VLANs to switch blocks. That's known as local VLANs. Building A, if it's got 2 VLANs, say 10 and 20, then make sure VLAN 10 and 20 stays in VLAN or in building A. Don't span that to building B, or else your trunk links will have to carry broadcast traffic over to other buildings. Not good. Second, implement a management VLAN. My rule of thumb is once you reach a network that has about 10 managed devices, I mean switches, wireless access points, routers, the whole gamut. Once you reach about 10, for your own sanity's sake, create a management VLAN, which is just a subnet dedicated to the management IP addresses of your switches, of your routers, and so on, that allows you to have a contiguous group of IP addresses that you can say, oh, 172.16.100, yep, that's my management subnet. So it makes it very easy and organizational when you're trying to figure out, well, what was that IP address of that switch? Very handy. Third, voice over IP is taking over the world, one company at a time, and that is why we need to separate our voice traffic, not only for quality of service, but also for security. It didn't take long, maybe a couple weeks after voice over IP started really becoming popular, that already hacking tools are out there allowing you to decode voice traffic and put them into WAV files. It's like a virtual butt set. So we need to separate our voice traffic to give it quality of service and also for security's sake. Finally, implement multicast support within the VLANs. That allows multicast traffic to be treated correctly by a switch. Because if you forget to do it and then somebody opens streaming radio or something that happens to be multicast, or wait, one of the big popular applications, Ghost, right? To re-ghost or re-image a machine back to its, say, factory-defined or corporate-defined image. Ghost is a typical multicast application that will eat your network alive if you do not turn on multicast support on your switches because they treat it like broadcast traffic. Those are your rules of thumb for implementing VLAN. As we dig deeper into the VLANs in the upcoming videos, we'll expound on each one of these. Last but not least, in this opening video to the series, is the 2 flavors of Cisco switches. And I shouldn't say this of the switches, I should say of the switch software. Cisco did not create the switch. They did create the router. They acquired some company that allowed them to get their switching technology, and it had a completely different operating system than the iOS. And Cisco was okay with that, and so were most people for many, many years. So that operating system has been, I guess, codenamed, if you will, the Cat OS. Every command, or just about every command that you type in there to configure something, begins with the word set. So if that's familiar to you, you've probably been working in the Cat OS. Cisco has typically combined that operating system with things like MSFC card, that's multi-layer switch feature cards, that give you routing capabilities within the switch, and that runs the iOS. So for years, we've been forced to learn 2 operating systems to work with Cisco's bigger switches, and it's usually the bigger ones that run the Cat OS, because we need to learn one for the switch itself and one for the router inside the switch. So within the last, maybe around 2002, 2003, Cisco began an initiative to start moving all their switches out of the Cat OS world and give them a native iOS feel. What that means is if you learn the iOS on the router, you know it on the switch, or at least the general syntax of it. Now, people fought that tooth and nail because people had learned the Cat OS and people loved it. It worked just fine for them, so why change? But change happens. And over the years, Cisco has made that migration nearly complete. You can still order your switches, your 4500 or 6500s with the Cat OS. It's still an option, but all of them ship, if you don't specify, using the native iOS because it combines the router and switch into one operating system and one device. It's much better once you get used to it, despite the still to this day some features being supported in Cat OS that aren't in native iOS and vice versa. So Cisco has a migration path for all mainline switches to native iOS. Sometimes it can be a big headache to do, but you can convert your old 6500 or 4500 switches over to the native iOS to unify the operating system. My point is this entire series will focus on the native iOS. Certification-wise, Cisco has removed the Cat OS from all certification exams as they've tried to slowly remove it from all their mainline switches. With that, let's wrap up the foundation of this series, the switch, and what we're focusing on in the local area network environment. We first started off by just, that was your 3-minute review of everything switch within the last 30 years or so. The evolution of LAN environments, moving from hubs to switches to layer 3 switches to multi-layer switches and so on. We then expanded that into the Cisco Enterprise Composite Network model, which deals directly with that campus network design. As your network grows, your bobblehead company expands, it's going to need redundancy. It's going to need routing. It's going to need VLANs. All of that is described in those 3 layers. Access, distribution, and core, divided up into switch blocks that populate your campus network. So we saw the campus network design looking at a high-level view of VLANs and where they fit into the big pictures, segmenting your network. Expect more on that in the upcoming videos. And then we finally talked about the switch operating systems, the Cat OS and the now called native iOS that can run on just about any Cisco mainline switch that you can buy nowadays. I hope this has been informative for you, and I'd like to thank you for viewing.